All right, we're live. Going to show you this new edition of the collection. Not that. Newest edition is this 25 kilowatt Edison Machine Works Edison Dynamo. You can see it compared here to a slightly smaller 20 kilowatt model, which I've moved over just behind it to make it a little easier to see some reference points. But this particular machine, unfortunately, was not so well cared for. Recently, a fellow collector was able to save it. Big thanks out to John Kriesel. I hope I got the name pronounced properly. John found this machine recently, and the story behind it is that it had been owned by a steam engine collector in Minnesota for quite some time, since the 1960s. The story says, and that he received it in trade from the Henry Ford Museum for a rare steam engine, which makes very good sense. That story all adds up, with the exception there's no acquisition number, as most Henry Ford artifacts have. But that doesn't mean much. We don't know when those markings, such as the one you see right here, were actually put on the machines. It's possible that they were done after the time that this machine left. Most machines that were in the Ford collection were in very nice condition, as you can see here. Unfortunately, this machine probably was very, very, very nice in its condition when it left the museum. However, the person who received it in trade most likely left it outside for decades. Most of these large machines that do survive because of Henry Ford. In the late 1920s, Ford made efforts to save early industrial equipment amongst all kinds of Americana, but with a special spot for Edisonia due to his close friendship with Thomas Edison himself. In many cases, these machines were found using original documents that Edison had supplied Ford with, such as sales records, etc. And some machines very likely came from Edison's inventory as well, as there were machines that were in that collection known for being exhibition machines. And one thing that's interesting about this machine is that upon closer inspection, there is evidence of pinstriping. And there are other known surviving ex-Ford collection examples, and possibly more still at the Ford Museum. We have a visitor here. Say hi. That were specially decorated, clearly very low usage machines that were used in exhibitions, such as the 1889 Paris exhibition. So there is a very good chance, with the provenance and the story behind this machine, that this could have been one of those exhibition models. This machine at some point was overpainted with what could have been, you can see the crackle here of that overpaint. It was probably a white latex-based or oil-based paint. Not sure why somebody would have done that, perhaps in an effort to protect it from rusting. But most of that has come off. It is on top of what appears to be original black paint, and then you can see the remains of the pinstriping under that. So very, very possible that this was a machine that was gifted to Ford from Edison, and we may never know. There might be some record at the Ford Museum that we can match up with this without an accession number on the machine. We really can't tell for sure. In 1982 and 1985, and I think maybe in the early 90s, the Ford Museum had a series of auctions where they deaccessioned many items to make room for new and budget for new projects, which is where machines like this came to be now in private collections. So this machine is an Edison Machine Works. Luckily, though no longer attached, the original builder's plates are attached. They've been recently media blasted, but they are the original plates. you'll see that this particular one has some condition issues. It was cracked and has been welded here. Most likely stick welded, not really how you want to, from a conservation standpoint, re-adhere cast iron. Brazing would have been more appropriate, or even better, just a conservation grade reversible adhesive. The Dynamo retains its original socket. It's seen better days. Interestingly enough, it arrived with the shell on it when that was removed. Most of what was inside fell apart. The socket is a Bergman socket. It's a little bit of an interesting one as a Bergman socket collector. This is what we would refer to as a fat shell socket that was made from about 1885 into the Edison General Electric era into the end of 1891, possibly into early 1892. Most Bergman fat shell sockets, in addition to patents, will state Bergman and Company, New York. This one does not have markings like that, which is the style of marking you would find on an earlier Bergman socket, which we'd call a skinny shell. So this is a bit of a crossover piece, kind of an interesting variant as well. The other thing that's interesting is that this socket is a surface mount socket, whereas most of the surface mount sockets that were made, the base was made of wood. This one is not wood and appears to be gutta percha, which might have been unique to use on dynamos where there was a more higher current needed and better insulation. You'll see that the headboard is pretty rough, so this is going to take some very special attention. The original fiber insulator rings here, they kind of show evidence that something happened to this machine. Something hit this, fell on this machine. This corner here that's heavily damaged on the headboard coincides with the damage to this plate. The lift hook here, hard to see if this really shows, but it is not level or plumb. To some extent, it looks as though it's been bent. It is generally unusual that they would stick out this far, and it does not move. So it is seized in the head block. So that will take some very special attention. This particular machine does not appear to have, or may not have had a canvas cover over the rear of the armature, as you see on this 20 kilowatt machine. It's hard to say. There are other surviving 25 kilowatt machines from the Edison Machine Works era that do have that cover. It's possible that the red fiber disc and the cover itself are just removed and missing. However, on the front, behind the commutator, we see string wrapped around the armature wires in lieu of a canvas cover to protect those sensitive areas. This string does definitely seem to be olden period. It's been on here a while and is very likely original. There are several photographs of much larger machines that have a similar approach to protecting those armature wires, and thus this probably is original. So the question is, what do you do with this? This machine's untouched original. It will stay that way. There's some cosmetic issues, but to remove the original paint, patinas, and surfaces and replace them with perfect paint would remove much of the history and historical context of the machine. This has survived as you see it from the day it was built. When something is this bad, generally the only option is to restore it. So the process is, thus far, I have photographed everything, used some color charts to make sure that we can see what this pinstriping color was. I'll go ahead and shave off some samples of that to save it so the colors can be matched. All of the metal will have to be stripped. There's really no way to save this. There's not much paint left. You can see some original black paint in these areas, but unfortunately the majority of it is gone. So the plan is to walnut shell blast all of the metal. It's very gentle. These pieces have been sandblasted, glass bead blasted, something like that. At least it appears to be. That removes 100% of any patina that's left on the metal and makes it look brand new. We don't really want to do that, even though we are going to repaint the machine. So walnut shell blasting is very gentle. It will make this metal clean. And yep, Stephen, you do see your old Splice in the background. Maybe we'll look at that. Really, really awesome piece. Yeah, pretty important piece in the context of my collection, showing the complete system of Edison's distribution of electric power. So this all of the metal parts will be repainted with an asphaltum-based paint, which is what they would have used in the era. Asphaltum is an asphalt-based product that is ground and mixed with solvents and produces a dark black paint. It was used heavily on all types of early machinery, and down to hand tools, wood planes, of course, electric fans, and Model T Fords. It is a paint that is generally baked on. Due to the size of this machine, I don't know if it's going to be able to be baked. That's going to be something that, hi Aunt Joanne, that is something that's going to have to be experimented with. I have several different formulas of asphaltum, both pre-mixed as well as just ground asphaltum. I believe it's Gilstein, or I can't remember the name. Anyway, so I'm going to try using some formulas that I found to mix the paint here, as well as some pre-made examples. One that is that does not require any type of heat to cure it. If it's found that heating does work well, the process that I have in mind would be to use some sort of cement board to form a housing around it and use infrared heat. We don't need a lot of heat, about 250 degrees, but a little more than we can get for the size of these parts from any type of standalone heat source, be it a torpedo heater, infrared heater, etc. The red fiber, these discs, they're really bad. On the bottom, you'll see that this piece has been pressed by something rubbing up or hitting the machine. Not uncommon. This piece will be reversed, will just be rotated 180 degrees. The edge will be cleaned up so that it's stable and cleaned, and it'll be rotated 180 degrees so the damage isn't so visible. The top, there's really not much can be done to salvage these at this point. I found a company in New Jersey that has been making this product for decades, if not well over 100 years, possibly one of the original suppliers, and have some samples on the way. And hopefully the product they describe matches this exactly. Aunt Joanne, when's the museum opening? I don't know, but anybody's welcome to come. It's not an actual registered nonprofit museum, but anybody that wants to come and visit this collection is welcome to. So anyway, I've got some samples on the way of that material. Hopefully it will be a close match. If not, I have a great faux finisher who will assist in making the new material look like the original material. Chances are I'll be able to remove both of these halves that remain, splice two of them together with a reversible conservation grade adhesive, and then only have to make one. The actual piece will have to be planed to thickness and turn on a lathe to get it exactly looking like the original. The head block will be removed. That'll be cleaned up using electrolysis, in which the whole entire piece of steel, based on measurements, this piece of steel weighs about 685 pounds. It will be submerged in an electrolysis tank. This piece in some surviving examples is a raw steel. In some cases it was painted. There doesn't appear to be any remains of original paint or ever having paint. So we'll go in electrolysis, in which through an electrolytic solution, the iron rust that is formed will be removed from the parent metal and transferred to a piece of scrap iron in the tank. One of the most complicated situations is going to be this headboard. So this is, laminated mahogany. There are 3 plies. Go to this original machine. You'll see how that works. You've got the front and back panels the grain is horizontal, and the panel in the middle, the grain goes vertically. So the plan here is to use as much as can be. The bolts, that is true. This particular bolt here, I was able to loosen with a wrench by hand. The other bolt is loose now, but was not. This is a 2 1/4 inch socket, so a pretty big socket used to loosen that. And I was able to use an impact wrench to loosen that. That was a major fear of mine. We'll go into how we're going to fix this situation here, but there is no access. A lot of times when a bolt is seized or rusted in place, you'll want to use heat, penetrant, whether it's paraffin wax, any type of oil, to wick into the threads and loosen it. Unfortunately, there's no way to do that. Through the steel block is a hole drilled all the way through, and the threads are in the center of this coil. There's no access to get any type of heat or penetrant into them. So luckily they came loose. We'll pull this out for a second just to show you the sheer size of this bolt. This machine would have been lifted and lowered into place. It's about 3,700 pounds using this lift eye. And we lifted it using that lift eye, using a forklift to get it in here. You'll see this is a substantial bolt. You can see how far the threads are down in what we call a blind hole in the core of the coils, the field coils. So the plan here is there's not much you can do to fix this. This whole piece will be disassembled. Areas such as this will be very carefully cut out enough to patch in a new piece of wood and blend it. Here, the same thing will be done. This crack here will be compressed and glued into place. All the work done on this will be done with a reversible adhesive. So in terms of a conservation respect to this piece, anything we do really should be reversible. Not that I plan to undo it, but this is a piece of history that's survived 130 years, and hopefully it'll be much longer than all of us. So for future ownership of this machine, whether it's in a private collection or a museum or other institution, should they want to, for whatever reason, undo any conservation work done in 2021, they should be able to do that. So in this case for wood, we'll use a hide glue, which is fully reversible just with steam or water. A new piece will be spliced into here. And right now the plan is actually to, again with a hide glue, adhere a piece of mahogany veneer to the face of this, blend it in the edge, and basically the repair, any damage should totally disappear. So once that's done, this piece, actually, as bad as it looks, will turn around pretty quickly. The coils, much of the rope is as you see, this is how it was found. Luckily, John, the true saver of this machine, found even more rope, which he sent me. all of this rope will be salvaged. It's very easy to just go buy some jute style rope and replace all of this. However, that would be removing a lot of the original materials, and you could save it with the piece for, later study, etc. But it's really best to try and make use of this. So Peter Dublin asked, where were these machines used and what purpose? I did say at the start, sorry about that. So these machines, this is an Edison Dynamo. So it generates 125 volts of DC power. The general propulsion method, let's see what way we turn this. You can see this pulley here. This is a big machine. This is, we'll go to this guy. It's a little easier to spin. It actually has oil in the bearings. This machine would have been spun at a high rate of speed, about 15 to 2,000 RPM, depending on its size. The typical means of propulsion would have been a steam engine. Edison in particular liked Armington and Sims. Or prior to that, he used, it's just in my head and I forgot it, Porter Allen machines. And a machine of this size was rated for 200 light bulbs. So 200 lights is based on a 16 candle power size lamp, about equivalent today to a 50 watt incandescent. And they base these machines based on the number of lamps. So if you were using 16 candle powers, this would handle 200. If you're using 8 candle power, it would handle 400. Or you could make a combination of both. The larger machine here was rated for 250 lights. So these could also be used as motors. In many cases, the smaller models very much were. You'll see down to a 0.5 or even 0.25 kilowatt. Those technically could be used to generate power for 5 or 10 light bulbs, but in general, they were used as motors for a single lathe, sewing machine, etc. Just a quick picture here. This is a blown up photograph, and this is the electrical generating station at the Edison Machine Works. So you can see in the background are large multi-cylinder vertical steam engines with their belts tied to Edison machines, very much like the one we're looking at now. So once this rope is cleaned up and all of this is stabilized and it's spliced together as carefully as can be so it's inconspicuous, this will start to look pretty good. So it looks really rough right now. One last thing. So the eye here, this is seized. Tried loosening it with a very large pipe and observed that the metal itself and the threads here were twisting, and which would break it despite how thick this is about 1.5 inches threaded drop forged steel, pretty strong, but it's based on the length of thread that's exposed here, which usually it's almost 3 times as much as typical. What will happen is this will be cut off. Basically just rough sawn off, and then a plate of thin aluminum or steel with a proper size hole cut in it that just protects this surface, even though it has to be cleaned of all its rust. It does have a texture here that's a result of the shaper, which is a machining tool which basically scrapes off chips of metal in a straight line. We don't want to disturb or damage that. So leveling it off as much as possible with just a basic die grinder, but using something to protect this surface so it can't be damaged by the abrasive. And then using a magnetic drill press, which will attach itself with a very, very strong magnet. Most are electromagnet. The one I use happens to have a rare earth magnet that doesn't require power for the magnet, but we can mount the drill press here and start to drill what's left of this out. Increasingly larger drill bits to the point where you have just basically a coil of thread left in the female thread which can be removed with a hammer and chisel. Then this piece will be cleaned with electrolysis, and the threads are pretty badly beat up. That'll just be redressed with a retapping die, and that piece that issue should be solved. All of the brass parts on here are in reasonably good condition. We don't want to polish them. Some people like to do that. These machines were not. This isn't like an antique fan. These machines were not. How much did it cost? We'll get to that in a second. Very expensive, actually. These machines were not meant to be beautiful. I think they're beautiful objects. They were professionally built. People took pride in what they did. But the hardware on this, in fact, this goldish tone you see here, is actually a good sign. It's possible that is surviving lacquer on the finish that is just yellowed. So these pieces, once they're cleaned up carefully so that the original patina isn't removed, they'll look pretty good. All of these bolts, they are all steel. That'll all be cleaned in a vapor rust, which is a really nice non-acidic rust reverser. Works really nice. It was instrumental on cleaning up this machine here, which is this is a 15 kilowatt Edison Machine Works machine. But all of this was very severely rusted, just like the other one in a vapor rust. Is inexpensive, and over the course of a couple days, really does a good job. So how much did it cost? I'd have to look at in many cases, you didn't buy just this machine, you purchased a system. So if this was, going back to where this was used, a machine of this size could have been used in conjunction with several others in a small local central station. As large as this machine is, as an object sitting here at 3,700 pounds, in the world of Edison Dynamos, as they were used on a large scale, this is a small machine. It's a 25 kilowatt. They went up to 175 kilowatt in this form, and they just got larger. Scale-wise, they look exactly the same. So eventually they got to the point where they were in the range of 25,000, 30,000 pounds. So a machine like this could have been installed in a factory, which would have made perfect sense. That factory would have had a steam or gas engine or multiple engines driving line shafts. Those line shafts would have run by belts all of the machinery in the factory, whether it was a machine shop or a garment factory. It would have all been run off of a line shaft. And that same line shaft could have fed this machine, which would have been used for lighting the factory safely. Imagine going from working in a factory with gas lighting, which is pretty nasty stuff. Emitted the smell of it, the soot, the danger of having an open flame, and this would have brought electric light. In many cases, if you had worked at a factory at the time that this machine was used, this machine dates to about 1887 to 1889. If you had worked in a factory that was electrically lit in this time, chances are you went home to gas lights. You came to work and experienced electric lighting for the first time. So as far as cost, the outfits for this, where you would get an installation essentially, would have ranged in the area of $2,000 to $3,000 at the time. Yeah, it's not counting for inflation. So just interesting talking about prices. This particular machine here is a much earlier, about 1884 to 85 Edison Machine Works Dynamo. And there's an interesting letter here to the Baltimore office, nonetheless, where they are in 1885 clearing out this machine to make way for the new style, which is the previous three machines we looked at. And they, at the wholesale price, they're looking for $500 at minimum, $500 or more, as much as you can. At the discount price on this machine, along with, and this supported about 50 lamps, along with lamps, sockets, wire, etc., regulator for adjusting the output of the machine, was $500 at the time as a closeout price. So anyway, there are actually two of this machine remaining in existence. There is this example also formerly from the Ford collection, and there is another example over at our friends at the Menlo Park Museum in Edison, New Jersey. Steve Skolberg, hope I'm saying that right, had mentioned the Edison Splice. Little mock-up here of a missing piece, but we'll take a break from the dynamo, almost done. So Edison, besides perfecting the light bulb to a commercially usable product, had to devise a complete system of electric lighting. So he had to perfect dynamos, which he certainly didn't invent, but redesigned and improved upon to reach a design that would be most efficient. And then he had to design fuses, sockets, switches, conductors, meters, all of that. Basically, none of that existed, and he had to develop the complete system. When power was distributed through from a central station to houses, businesses, etc., much of the wiring was run underground. This is an underground splice. These pieces of what were called Edison tube were manufactured in 10 or 20 foot sections. You'll see this. This example has been prepared very nicely, where there you can see some rope here. The conductors are separated by rope braided around them, and then it is filled with tar as the final insulator and water protectant. These were spliced at the end of every length below ground, and this is what the splice looks like. These laminated joints here are somewhat flexible, so vibrations wouldn't cause them to break. This would have been connected, and then the lid attached. This would have been filled to the top with tar, and then a lid would have been put on top. This particular lid is a 3D printed replica of what the original lid would have looked like. Shout out to Aaron Loyak for the really amazing work to draw the CAD file to make this, and running, we'll get to that in a second. Did the CAD file for this. We took measurements, and it was 3D printed, and the printed model arrived in a couple weeks, and it fit like a glove the first time. So pretty amazing piece. There were certainly a lot of these made, but as you can imagine, being buried underground, these were used in large jurisdictions of where early systems were installed. This particular example was found in San Francisco and was installed when they put in their 3-wire Edison system in 1890, and was dug up during a project in 1979, and thankfully was saved. Most of these would have been either destroyed, and some certainly still exist underground. You just can't go and get them. So as much as it's not the prettiest thing, and it's not a car rear differential, which some people think when they come in here, it's not the prettiest thing, but of all the pieces from the Edison system, from the meters to the switches to the rheostats, all of that's really hard to find, but this particular piece is an odd missing link that's just really, really difficult to come across. So as far as running, some smaller examples of these that I have owned in the past, I have run as motors. This particular size, something this big, requires a lot of DC power to run it as a motor. And I can post some pictures as a follow-up of some machines running as motors. Running as a dynamo, you could use an AC motor and a pulley and link it up and spin it, and they would work. I've never done so. A fellow collector in Pennsylvania who sets up at the Cool Spring Engine Show every year sets up two small 0.5 and a 0.75 Edison Dynamo along with a small gas engine, and runs them and lights up light bulbs. It's a big hit there. So anyway, that covers this machine. I think I've answered all the questions. Going to continue to cover the restoration of this. Hopefully in, I don't know, the next 6 months or so, this machine looks a lot different when you see it next. Thanks a lot, and see you in the next video.